Hey students, how you doing today? Mr. Elliott here. Happy November 1st. I hope you had yourself a wonderful Halloween and a good night's sleep last night so that you will be ready for the day. Today, I don't know. Anyway, today's lesson is called Roots and Fractional Exponents. We're going to need this for a couple different reasons. If we look at our objective sheet, this is specifically objective 2H, the last objective on our list. I can solve an equation using fractional exponents. That'll be the last thing that we do with my lesson today. But the first thing we're going to do is set up what's going to happen on not this lesson, but tomorrow's lesson. And in that one, we're going to be rewriting rewriting expressions that are either in radical form or exponential form. For example 1, I'm going to give you the cube root of x, and we are to rewrite this expression in exponential form. And I'm just going to run through some really fast examples just to show what's going on here. So if you had the cube root of x, I don't know how else just to throw it at you. This is the same thing as x to the 1/3. Or another one, if I had the 7th root of x, that's the same as x to the 1/7. And if you think about something like an equation, let's go with if the square root of x is equal to 8. Well, we learned to square both sides of this and end up with x equals 64 by squaring both sides. So if you thought about it as a fractional exponent, whenever there's no number here, like this was a cube root, so it was 1/3. Whenever there's no number there, it's kind of assumed that it's like a 2. Kind of like if you write x by itself, that it's assumed that there's a 1 out front. Same thing, if you just write a plain old square root, it's assumed that there's a 2 there. So a square root is the same thing as x to the 1/2. And if I had x to the 1/2 equals 8, that's the same thing as the square root of x equals 8. Well, how would you get x by itself? Well, by raising this to an exponent of 2. 1/2 times 2 is 1, so you get x to the 1, and 8 squared is 64. That's kind of the reasoning behind fractional, how a radical ends up like an exponent like that. So what if it's something like example 1, so it's the cube root, excuse me, I got a cough, the cube root of x squared? Well, instead of being a fraction of 1/3, it would then be a fraction of 2/3. So what's inside the radical becomes the numerator, and what's outside the radical becomes the denominator. I just got a ton of quick examples here. 7th root of x to the 5, inside numerator, outside denominator, so x to the 5/7. Sometimes you may have more than one variable in there, so let's say it was the 7th root of x to the 10 and m to the 4. Well, you just need to apply this fractional exponent to both the 10 and the 4. I guess one way you could look at it is that this is x to the 10, m to the 4, all to the 1/3 power, because it's now in exponential form. And then if you distribute through using that power rule, you end up with x to the 10/3 and m to the 4/3. You could have just done that straight away and avoided this middle step too. Okay, so that is rewriting in exponential form. You're going to be asked opposite questions too. So part 2, rewrite in radical form. Oops, where is that? Rewrite in radical forms down there. Okay, so on that one, I would give you something like x to the 1/3. And you know, in our previous problem, the 1/3, that meant cube root, so just the cube root of x. And there's no exponent on the 1, but it would be the 1. Or there's no exponent on the x, but if there was an exponent, it would be 1 for the numerator that was there. So for example, 2, if I had x to the 8th third in radical form, that is the cube root of x to the 8th. Now this isn't simplified, but this doesn't say to simplify, it just says to rewrite it. So we're not going to worry about simplifying today. We're going to simplify this one on tomorrow's lesson. If I had x to the 2/5, same thing. We're talking the numerator goes on the inside, so x squared, and because the 5 is on the denominator, it's the 5th root of x squared. This happens with variables, but it could be numbers too. Let's say it was 6 to the 4/5. Excuse me, let me get some water. But denominator tells you the root, so 5th root of 6 to the 4, and I would leave that problem just like that. That's Elliot reaching for some water. Okay, last one, example number 5. Let's say I had x m raised to the 6 over 5. So the denominator tells you the root, so it's the 5th root, and then that 6 hits both the x and the m, so x to the 6th, m to the 6th. Okay, that's rewriting in radical form, and these are things. This is just setting us up for what's going to be happening in tomorrow night's lesson. Now, part 3, we're now going to get into some. Part 3 is a little bit different. We're now going to solve for x. Example 1, let's say I had x to the 2/3 equals 4. All right, so if I think back to that example I talked about a couple minutes ago. So when I had x to the 1/2, I raised both things to an exponent of 2 because 2 times 1/2 is 1. So I'd get x to the 1 equals 64. It's the same idea here. Because the exponent is 2 over 3, you got to think reciprocal. The reciprocal of 2 over 3 is, of course, 3 over 2. So by raising both sides of the equation to the power of 3 over 2, over here, 2/3 times 3/2, these cancel out, and you end up with x to the 1. Over here, you have x to the 4 to the 3/2, and this needs to be simplified. Now, you have a couple different options. You could think of this as being 4 to the 3rd power raised to the 1/2. Or you could think of this as 4 to the 1/2 raised to the power of 3. You're going to get the same idea. But basically, do you want to cube something first, or do you want to square root something first, or root something first? In this particular case, I'm going to root it first because these are non-calculator problems, and you might not know what 4 to the 3rd power is, but 4 to the 1/2, that's the square root of 4, which becomes 2. So this becomes 2 cubed, and 2 cubed is 8. If I thought about it the other way, 4 cubed, that's 64, and then 64 to, sorry, that's to the 1/2. 64 to the 1/2, square root of 64 is 8. So you can solve these either way, but because these are non-calculator problems, I'm going to use this technique first, where I am doing the root first. Example number 2. Let's say I had x to the 3/2 equals 64. So same idea. The reciprocal of 3 over 2 is 2 over 3. So we're going to raise both sides of this equation to the power of 2/3. On this side, the 2's and the 3's cancel out. I'm left with x. On the other side, I'm going to do the root first. So I have 64 to the 1/3, all that squared. Well, 64 to the 1/3, if you think about that as a root, that's the same thing as the cube root of 64, and the cube root of 64 is one that you need to have memorized. It's 4. and 4 squared is 16, so x equals 16. Last non-calculator example today. Let's say I had x to the 4/5 equals 81. Ooh, Elliot's voice. All right. The reciprocal of 4/5 is 5/4, so I'm going to raise both sides to the power of 5/4. 4s and 5s cancel out. I'm left with y by itself. Over here, I'm going to do the fractional exponent first. So I have 81 to the 1/4 raised to the 5th power. On the side, 81 to the 1/4, that is the same as the 4th root of 81. And you need to know that that's equal to 3. So I have 3 to the 5th power, and 3 to the 5th power is on the list. That happens to be equal to 243. All right, these are non-calculator problems, and if I remember this from last year, we put non-calculator problems on the quiz and on the test, so you need to know how to solve these problems without a calculator. But in your daily practice, you're going to see problems, some involve the calculator, some don't. So let's do a couple problems that that do not, wait, what am I saying? Let's solve some problems that do involve the calculator. Okay, so yeah, let's see, that one, no. So if I had 4th root of x equals 7, if they give it to you as a root, as a radical, you're going to want to change it to an exponent first, so it becomes x to the 1/4 equals 7, which means to solve this one, you're going to raise both sides to the 4th power. Now, 7 to the 4th power, that is not one on the required list, so you can always use your calculator for this. As I've shown in the past, 7 to the 4th power, 7, use this button right here, 7 to the 4th power, and when I hit enter, it gives me an answer of 2,401. All right, example number 5. X to the 7/3 equals 100. All right, so just like our previous problems, we have to raise this to an exponent. In this case, it would be 3/7, because that is the reciprocal that allows this to cancel out on the left. You're left by x by itself over here, and over here you have 100 to the 3/7 power. Well, if you try to do this by hand, you have 100 to the 1/7 power, all that cubed. We don't know 100 to the 1/7. That would be a weird answer. So we're just going to use our calculator. And 100, well, so if they want an exact answer, this would be your exact. But the instructions, I believe, would tell you to round your answer to the nearest thousandth. Well, it says to 3 decimal places, so nearest thousandth. So if we do that, you go 100. So 100 to the, use parentheses, 3/7, was it 3/, yeah, 100 to the 3/7, close parentheses, and I got 7.197. 197. And I guess because it went to a decimal approximation, I should say it's approximately 7.197. And that's example 5. One more example. Example number 6. If it's the 4th root of x cubed equals 6. So you're first going to want to think fractional exponents. That gives me x to the 3/4 equals 6. And now you're just going to raise both sides to the 4/3 power. Over here, 4s and 3s cancel out. X is left all by itself. On the other side, 6 to the 4/3. So 6 to the, parentheses, 4 divided by 3, close parentheses. And I got 10.9 0, and it's a 2/7, so that would round up to a 3, so 10.903. And because this was a decimal approximation, I should probably use an approximate there. Okay, so that's solving equations using fractional exponents. I guess the last thing I could do as an example is like example 2, where I said x to the 3 halves equals 64. Well, maybe it wouldn't read like that. Maybe it would read like x, or I guess square root of x cubed equals 64 is what it would look like. But you change this to a fractional exponent, so it becomes x to the 3 halves equals 64. And then you would just raise both sides to the 2/3 power. And this is, once again, this is just me redoing number 2. If instead of them asking like a fractional exponent, what if they asked it as a root? Anyway, on this, 2's and gone. Cube root of 64 is 4. 4 squared is 16, so 64 to 2/3 is 16. Okay, everybody, that is all I have for you today. I hope you enjoyed this lesson. And it's important to have this, at least parts 1 and 2 completely mastered by the start of class, or by the end of class on Wednesday, because Wednesday night's lesson, I think Wednesday night's lesson is going to be simplifying roots, and that's going to be a pretty intense lesson for a lot of people. So I hope you're up to date. Have yourselves a great day, evening, wherever it is you are in your life, and I'll see you tomorrow. Bye-bye, everybody.